Welcome to the Adirondack Sky Center and Observatory. There's nothing more inspiring than the night skies in the Adirondacks. It just makes sense to start your visit to the wilderness above with us. Our current programs focus on immersive experiences for audiences of all ages. They reach as close as into our own community and as far away as students from around the globe. From inspiring presentations given by some of our friends as world experts, to our Keystone 4-day astrophotography conference, there's something for everyone, including live as well as virtual stargazing, customized programs for schools, and private events. In the case of the Adirondack Sky Center and Observatory, the sky is certainly not the limit, but only the beginning. A second building is currently in the planning stages in the form of an Astro Science Center and Planetarium. This 18,000 square foot building will be dedicated to the study of astronomy and space travel. The planned $15 million Astro Science Center will feature a state-of-the-art planetarium under a 30-foot dome, a 100-seat theater, and a large area for hands-on and interactive activities. Our many exhibits will include a Foucault pendulum, overhead models of the solar system, and historical permanent as well as traveling collections. It's our mission to make this an immersive experience for everyone. You will never be told to look and don't touch. This new building will be in addition to our existing roll-off roof observatory, which houses 4 permanently mounted telescopes. The final phase of construction includes a traditional observatory dome housing a new 22-inch research-grade telescope. Please contact us to become a member or make a donation to help build this new Astro Science Center and Planetarium and begin your journey to the wilderness above. And with that, I'd like to welcome everybody to the Adirondack Sky Center and Observatory's presentation of a walk around the winter circle. My name is Seth McGowan, and not only am I the vice president of the organization, but I'm also your tour guide for tonight. So I see a ton of people on here. This may be a record turnout. I see lots of friends, lots of family too. Hey guys. And a special shout out to Miss Bartlett's astronomy class from Carthage High School tonight. Great that you could be here. I'm psyched. So as you heard, the Adirondack Sky Center and Observatory is dedicated to astronomy, space exploration, and bringing the wilderness above to Earth for everybody. And while I am the vice president, I do want to give full disclosure tonight that I am not an astronomer. I'm not a scientist. I'm a recently retired superintendent of schools. And the reason I mention that is because astronomy is really accessible to everyone at every age, at any stage. So we shouldn't be afraid of astronomy, maybe as we've been, but embrace it. The new building that I mentioned during the video is just going to be a spectacular and significant addition to not just Tupper Lake, but the entire Adirondack Park. So I hope you consider becoming a member of the Adirondack Sky Center and Observatory. Better yet, make a donation to us, help make this project a reality. And further, if you're interested in or thinking about making a substantial donation to the Astro Science Center in particular, we'd want to talk to you in person directly. So you can contact info@adirondackskycenter.org so we can talk more in depth about that. And I'll provide some of our contact information at the very end of the presentation tonight. So tonight we are going to travel counterclockwise through the stars and constellations of an asterism known as the winter circle. Along the way, we'll look at some of the details of each of the stars, their size, their temperature, and compare them with our own star, the sun. I'll pepper in a little bit of classical mythology associated with the constellations, and if time permits, we'll take a look at some of the beautiful deep space objects that our own photographers from the Adirondack Sky Center have captured. So sit back, relax, and let's get started. First off, a little clarification. You probably heard me use the word constellation already, which is a term you probably know and have heard before. And I also mentioned the term asterism, which you may have heard but whether you know it or not, you've certainly experienced it for now. So, by definition, and by loose definition, I'll say that a constellation is a designated area of the sky, designated by the International Astronomical Union, in which a specific group of stars live, and if there's a boundary around it. Often those stars outline a pattern, an animal, a person, a creature, or some other important object typically associated with Greek or Eastern, Native American, or other cultural mythology. Usually has some fantastic story behind it. But the truth is, constellations are often hard to actually imagine. You have to have one of those, I don't know if it's right brain or left brain, but you have to have an extra brain sometimes in order to actually see what those stars create. Asterisms, in contrast, are the exact opposite. They are intended to be obvious, visually obvious. It's like a gigantic game of connect the dots on a galactic scale. One of the great differences or obvious examples of the two of them is the Big Dipper, which is an asterism, contained within Ursa Major, the Great Bear, which is a constellation. So on our screen right now, you can probably identify this group of stars. I want to say raise your hand if you've seen it before, but that might that might be counterproductive. This is the Big Dipper, and you've probably seen it before, but there's no doubt that this looks like a pot with a handle, and it doesn't take much imagination to identify that way, especially when we turn on the outline for it. So obviously a pot, not a whole lot of question about that. Ursa Major, however, the Great Bear, is a designated constellation. It has a great story behind it, but not necessarily as easily recognizable. In this example, the Ursa Major constellation is in this area. And if you're familiar with it, then of course you can see it and you can use your imagination. But if somebody just tells you to look up in that area and imagine a bear, uh, I don't know about you, but I'm not going to come up with it right away. I happen to know this is about where the head is. These two stars I usually look at as a front paw. Here's a back paw, these other two stars. And these two stars are the back leg, maybe. And Ursa Major has a long tail, and there's a great story behind that also. But without really some help, you might not see that pattern of stars there. So here's without the pattern, and here's with the pattern turned on. And of course, the Big Dipper, the tail of the Big Dip of Ursa Major makes up the handle of the pan. So this is a great example of how Ursa Major, the constellation, contains an asterism inside of it. And that's sometimes the case, sometimes it's not the case. Sometimes asterisms appear on their own without necessarily being inside of a constellation. But in this case, it's a great example of what an asterism is and how it makes up part of the constellation. So now it's time to turn our sights towards our featured asterism tonight. And the reason I mention it is because, unlike the Big Dipper and Ursa Major, the asterism that we're going to look at tonight contains several different constellations. And here's the asterism that we'll start with tonight. In order to find this asterism, you can start by turning facing south, and I'll turn on the meridian line for us, which is that imaginary line that cuts the sky in half from east to west. And I'll turn on the zenith also, which is that spot that when you stand anywhere on Earth and you look up, that's what will be right above you. This is the vantage point from Tupper Lake. Now, if you were to face south at this particular time, it's 7 o'clock or 7:13 on Thursday, March 4th, 2021. This is what the sky looks like. If you look straight above your head from here, right next to it is this star called Capella. And we'll look at that in some depth in a few minutes. As we curve around this massive circle in the sky, we hit two stars we'll look at, another star, and right at the 6 o'clock position is Sirius, the big dog star, the brightest object in our sky. We'll come back to that in a bit also. We curve right back around and right back up to the top. So we can see that even though that's an imaginary circle in the sky, it's actually a defined asterism, and it contains not just one, but many, many constellations. And we'll go through these tonight in some detail. I'll tell you a little bit of the stories, and we'll look at the stars on them. So that's the winter circle. It's also, by the way, sometimes referred to as the winter hexagon because you can see it has a little bit of a hexagonal shape to it. And as we go counterclockwise through it, we'll stop at each of the major stars. Okay, so I'm going to turn the zenith and meridian off for the time being. And we'll start at the very top of the circle, Capella. And that constellation, or that star is found within the constellation of Auriga. But first things first, to be fair, if we're going to be looking at other stars in our universe, in our solar system, I think that it's fair that we should start with our own star, the sun. And this will help give us a little bit of perspective on what things are. Although we're going to be looking at many different animations and graphical representations of things tonight along the way, I'm going to pepper in some of the photography that our own board members have done and other members of the Adirondack Sky Center. This is not a drawing or a painting. This is actually a photograph done by Tim Connolly a couple of years ago. Tim Connolly maintains his own site, Astro North, and he does unbelievable astrophotography. He's one of the featured photographers that works for our astrophotography conference held in the fall of each year. And we could talk more about that later. But this is a real picture of the sun, and I just think it's stunning. So I wanted to share that with you. Now, from a comparison standpoint, the sun is a star that is 4.5 billion years old, and about a million Earths can fit inside of the sun. We can see a graphical representation. I'm gonna just hit mute all. There we go. Uh, this is the Earth in comparison to the entire size of the sun. And here, just by comparison, is Jupiter, the biggest planet in our solar system. And on an enlarged basis, you can see that Earth seems kind of puny even compared to Jupiter, let alone the entire sun. The sun is about 865,000 miles in diameter, while our teeny little Earth is only 7,900 miles in diameter, about 109 times bigger than the Earth. The sun is about 109 times bigger. But even more importantly, the sun accounts for 98% of all of the mass in our solar system. So if you took the sun and added Mercury, Venus, the Earth, Mars, all of the planets, all of the moons, and everything that's in our solar system, 98% of that weight would be the sun. And you can see it's a big guy, so it makes some sense. The surface of the sun is called the photosphere, and it has a temperature of about 10,000 degrees Fahrenheit. And we'll look at the different temperatures of the stars as we go through. However, at the core of the sun, the temperature can reach 27 million degrees. 27 million degrees. So here in Tupper Lake, it's about 6 degrees right now. I would borrow a couple of those 27 million degrees and make it a little bit warmer here. The sun is about 93,000 miles, sorry, 93 million miles from the Earth on average. This is referred to as an astronomical unit, and it takes light 8.3 minutes to get from the sun to us. So if somebody were suddenly flip a switch on the sun and turn it off, we wouldn't know about it for about 8 minutes and 20 seconds. Plenty of time to find our flashlights or our glow sticks or something along those lines. Just as a note, light travels at about 186,000 miles per second. That in real time is about 670 million miles an hour. So that you certainly get a speeding ticket for that. As far as what the sun is made of, most of it, 92% of the sun, is made up of hydrogen. and about 7% is made up of helium at the core. And there's other gases in there also. But the important part is that every second, every tick of the second hand, the sun burns 7 million tons of gas every second. That is mind blowing to me. I've got a 500-gallon oil tank in my basement, and I'm glad I'm not going through it at that rate, although sometimes it feels like it. So now that we have a point of comparison, we can start our walk around the winter circle with where we left off just a minute ago, with the constellation of Auriga and the star Capella. Uh, the the Auriga constellation gets its name from Latin, and it means charioteer. Its major stars, I'll zoom in just a little bit, its major stars kind of create the shape of a helmet that a charioteer might wear. But mostly, this charioteer here is identified as the king of Athens. And he's important because he tamed 4 horses and attached them with a harness to horses for the first time. He was the first mortal to do that. Certainly, Helios and Apollo, who were responsible for dragging the sun across the sky, had done that. But Zeus was so impressed that he decided upon his death that he would place the king of Athens in the sky as a charioteer. And I'm so glad he did. Otherwise, we would never have had that great scene in Ben Hur like we did. The star here, there should be enormous laughter right now. If there's not, I'm going to be terribly disappointed. The star that we identify as being on the asterism of the winter circle is Capella, and this is no accident. You'll notice that Auriga is holding this goat. This is a little goat. In fact, it's a little she goat, and little she goat in Latin translates to Capella. And this little she goat is associated with Amalthea, and this is no accident. Amalthea was the foster mother of Zeus. When Zeus was born, his mother Rhea was afraid that her husband Cronus would eat Zeus. And this is not for no reason. Cronus had a reputation. He had already eaten all of the rest of the kids. So she wanted to protect Zeus. She brought him to a mountaintop and gave him to be raised by Amalthea, which she did until he was old enough to come back and conquer Cronus and become the Olympian god that he is. So that's the story behind that constellation and that star. Let's deconstruct or the Auriga constellation a little bit. Here's the same constellation. Here's Capella, note still attached to the little goat here. But let's look at it in a 3D standpoint. When I think of constellations, maybe a little naive, I tend to think of constellations as being painted on a canvas in the sky. But one of the things we're going to pay attention to tonight is that that's not really true. If we kind of go around the back of the constellation, we can see that even though Capella is here, there's a number of other stars in a variety of sizes and temperatures that make up the constellation. And more importantly, there are a number of different distances from the surface, what we would imagine as the canvas of the constellation of Auriga. And we'll kind of take that look for each of the constellations we look at tonight. But for now, let's go back to Capella and let's see where in our galaxy they are. Let's get oriented here a little bit. You should now see the Milky Way galaxy, or a rendition, an image of the Milky Way galaxy with these various arms that outstretch from our spiral galaxy. Here is the core, and around the edges, of course, is the edge. We are located, this major arm here is the Sagittarius arm, but we're not actually in the Sagittarius arm. There's a little spur called the Orion spur. And let me zoom in a little bit. We'll concentrate on the left side of the screen here. This is the Orion spur, and this is the Perseus arm. So we're going to concentrate mostly on the Orion spur tonight. But if we look at where Capella is here, and our sun is here. We are kind of in this region, this little lagoon area, I call it. This distance from the sun to Capella is 42 light years. So traveling at that 186,000 miles per second, it would take 42 years to reach Capella from there. So that's sort of the orientation of Capella. Everything we look at tonight is really going to be in this little area here. We don't really stretch out very far among the other areas of the Milky Way galaxy. But let's take a closer look at Capella itself. And you'll notice that even though Capella looks like one star to us when we look at it in the sky, it's actually made up of four stars altogether. Two of them are these large binary yellow stars, and they are about the same temperature as the sun, about 10. What did I say? 10,000 degrees. I honestly, I've kind of lost that a few seconds ago. Um, it's these here's the representation of our sun, so you can see in size that these are much bigger, about 80 times brighter, and about 10 times the diameter of the sun. Both of these stars, as opposed to our 4.5 billion year old sun, are 50 million years old, and they're cooling and they're expanding, so at some point they're going to become red giants. Uh, these massive objects are only 60 million miles apart, or two-thirds the distance between the Earth and the Sun. So remember, the Earth and the Sun are about 93 million miles. These are only 60 million miles apart, and they're rotating around each other. They never, from our vantage point, never pass in front of each other. And that's known as a non-eclipsing binary star. They circle each other about once every 104 days. Now, you know, our orbit around the sun takes 365 days. At 60 million miles and 104 days, these two are spinning pretty quickly. The other two stars are these two little red dwarfs. They don't really necessarily add much brightness to it. It's mostly these two binary stars that lend to the brightness of Capella. So that's the story of Auriga and a look at Capella. And keeping in our plan, we're going to continue around the circle counterclockwise so that we reach the constellation of Gemini. And Gemini is identified by two stars, Castor here and Pollux, and they're in mythology as identical twins. Castor was a mortal as a horseman, and Pollux was immortal. He was a son of Zeus and a great warrior. They were both on board for Jason on the Argo during a terrible storm. They saved the ship from sinking. So they have sort of a sea history. Ultimately, Castor was killed in battle, and these two brothers were so devoted to each other that Pollux pleaded with Zeus to bring him back. Zeus didn't do that, but he said that he would immortalize them in this constellation, but only half of the time. And if they spent half of the time on Earth, half of the time in the sky. And so that's how they got to be among the stars. Since then, because they have this sort of nautical history, it's believed that when you can see both Castor and Pollux in the sky at the same time, you'll have smooth sailing. However, if there's a cloud or something obscuring either Castor or Pollux, things might not end well for your voyage. So beware. Let's take a look at this constellation in the same view. Here's Gemini, and here's Castor and Pollux on the head. Let's take a look and open up Gemini. Again, Castor and Pollux. We spin them around and we can see a variety of different types of stars in the constellation. And even Castor and Gemini are quite a bit different as well. So there's the 3D version of Gemini. Let's take a look at where they are in our Milky Way galaxy. Here again is the Sagittarius arm and the Orion spur. Let's zoom in a little bit here. Remember, Capella was about 42 light years away. Here's Castor at 51 light years, so a little bit further away, and Pollux only 34 light years away, so even closer than Capella was, but still within that lagoon area of the Orion spur off of the Sagittarius arm. So we're not going very far, at least not yet. Maybe we will in a little while. From a data standpoint, here's a rendering of the sun and Castor, this white star, bluish whitish star, and this yellow orange of Pollux. These stars are about 725 million years old. Again, Earth, our sun, 4.5 billion. Castor is the 23rd brightest star in our sky, while Pollux is the 17th, a little bit brighter because of its size. Castor is about 3 times the size of the sun in diameter, and Pollux is about 9 times or so the size of our sun in diameter. Now, you know that the whiter things get in space, the hotter they are, and the redder they get, the cooler they are. So you can probably guess that the temperature of Castor is hotter than our sun, weighing in at 16,500 degrees, whereas Pollux is much yellow oranger than our sun, and actually cooler, in fact, than our sun at 10,000 at 8,000 degrees, as opposed to our sun at 10,000 degrees. So there's a view of Castor and Pollux within the constellation of Gemini. Moving counterclockwise again, we have the constellation of Canis Minor, and we have the star of Canis Minor, Procyon. Canis Minor is a small constellation, only 2 stars in it, and it translates as the lesser dog. Somebody has to be the lesser. There's a big dog coming up in a few minutes, so Canis Minor is the lesser dog, and the big dog is Sirius. We'll get to that in a little bit, but we can see that Procyon here, Canis Minor, the constellation here. Let me see if I can get that to happen in 3D view. There we go. A much simpler version of a constellation, only the 2 stars, Procyon being the cooler of the two, and its companion star in Canis Minor being a blue star. If we look at Procyon, actually, I forgot. I wanted to show you where in our universe, in our solar, in our, let me try that one more time. In our galaxy, Procyon is. We zoom in here, and we are again not that far. This is the closest one yet. This is only about 11 and a half light years away from us. Now, we say that that's not far, but that is quite a significant distance. But again, we're still in that little lagoon area. Haven't really left that region at all so far. So now we can look at Procyon a little bit better. Procyon is not necessarily all that bright, but because it's so close, it seems brighter than it should be. Procyon is 1.7 billion years old, so it's about the third of the age of our sun. It's about 1.5 times the mass of our sun. It measures in at 11,000 degrees Fahrenheit, uh, twice the diameter, about twice the diameter of our sun, 7.5 times more luminous. This is going to continue to expand to 80, between 80 and 150 times in size over its life, which is expected between the next 10 to 100 million years. And frankly, that's as exact as I'm prepared to be tonight. So we'll just have to leave it at that. That's quite a range, I know, but that's what I know about Procyon. Let's continue around now to the bottom, or the 6 o'clock position. I'll zoom out a little bit. We started with Capella up on top in Auriga, and now we're at Sirius on the bottom in the 6 o'clock position. And Sirius is located within the constellation of Canis Major. So Sirius, actually, the name Sirius comes from the Greek meaning searing or scorching. This is the, as I mentioned, the dog scar. This is the bigger dog, and of course, Procyon was the lesser dog. And the reason that Procyon is the big or is the little dog is because Sirius is simply the brightest star in our sky. There's no argument about that. But its name Sirius comes from the word for searing or scorching, and it rises in late summer, August area. So it was thought that because it was so bright and the sun was also in the sky, that when Sirius came up, that it added heat to Earth or to our land, and it made things hotter than it would be with just the sun. So with Procyon, Sirius, and the sun, this is where we get the term the dog days of summer from. They're so hot. Sirius is the fifth nearest star to us, and it is actually going to be the closest star we see tonight. This weighs in at a neighborly 8.5 light years from us. So this is very close to us, which also lends to its brightness. Again, still in that little lagoon of an area, without much space between. Sirius is has an apparent magnitude, and we haven't talked too much about what that means exactly. But when we talk about magnitude, negative numbers or lower numbers going to the negative side mean brighter. So Sirius is the first object that we see that has a negative number of 1.46, minus 1.46. As things get dimmer, the magnitude number gets higher. So as I mentioned earlier, Sirius is the brightest star in our sky. It's in fact a double star, as was Capella and some of the others as well. Sirius is about 300 million years old. It's a white star. It's 23 times brighter than our sun. And remember that Castor was a similar-ish star, measured the same temperature, 16,500 degrees Fahrenheit. So this is similar to the temperature of Castor from Gemini. It's about one and a half, almost two times the diameter of the sun, a little bit less, and 2.35 times the mass of our sun. So as I mentioned, it's a double star, and its companion star is actually a white dwarf. And this is fascinating to me, is that the white dwarf is actually smaller than the Earth. You remember earlier we saw the sun with Jupiter and the Earth next to it. Earth was just a little dot. This white dwarf of Sirius is actually smaller than that, but it's dimmer than the sun, but it has a mass that's similar to ours to this size, but 50th the size it's 50 times smaller than our sun. So take the sun's mass, crush it into something that's smaller than the Earth, and you have unbelievable density in that white dwarf. So that's a fascinating phenomenon. We don't even necessarily look at it. This, if I'm not mistaken, and somebody might correct me if I'm not correct about this, I want to say that this white dwarf associated with Sirius was the first white dwarf that we actually ever discovered as astronomers. Somebody can stick something in the chat if I'm right or not right about that. Hopefully, I am. All right, moving around our winter circle, we come to one of my favorites, and that is the constellation of Orion. And his ankle star, we'll refer to as his ankle star, is Rigel. Now, Orion, in defense of tonight's program, we could probably take a full week and do a program every night about the mythology of Orion. But we'll cut it short tonight. This is a family program, so we don't want to get into too many of the details. Suffice to say that Orion was born under very strange circumstances. We'll leave it at that. we have a more adult show later. We can get into that. He grew up to be a mighty hunter, and after being blinded and wandering the sea for years and years and years, he finally landed and met his friend Artemis, who was the god of the wilderness and the protector of the animals, also responsible for the moon, moving the moon across the sky, as her brother, her twin brother, Apollo, was for bringing the sun across the sky. So she was a great hunter. He was a great hunter. They hunted together, yada, yada, yada. Orion made the fatal mistake, I'll call it, of bragging a little bit and saying that if he wanted to, he could kill all of the animals in the forest. Well, needless to say, Artemis was disturbed by this, and that ultimately led to his death. One, because Apollo was getting upset at the relationship between Orion and Artemis, and he was, a little bit of a tattletale. He ran to his grandmother Gaia, and she wound up sending a scorpion down to kill Orion, which is ultimately what is said to have happened. And that scorpion is now Scorpius in the summer sky, and Orion in the winter sky. They're said to be chasing each other around the heavens. The other is more of your classic Greek tragedy, and that is that while Orion was bathing at the far end of a lake, um, Apollo challenged Artemis to a shooting contest. And Apollo knew that Orion was on the other end of the lake, but Artemis did not. And Apollo took his shot and he missed, and then challenged his sister to take a better shot. And she did. And she accidentally killed her friend Orion. And she was devastated by this. She begged Zeus to bring him back, bring him back. Dad, I'll never ask for anything again. I know my daughters are on the phone right now, right? You've heard that before. Um, uh, Zeus didn't do that, but in standard form, Zeus stuck him in the sky, and that's why Orion is in the sky now. So that's the abridged version, the very abridged version of the story um, of Orion. Hey, we didn't actually look at Canis Major in the sky. I think we're going to have to skip that for now and take a look at the Orion constellation in 3D. Note his famous belt, also an asterism. Let's take a look at that 3D version of Orion. Here's his belt here. Here's another star we're going to look at in a little while, Beetlejuice. But if I flip Orion around, look at what happens to that belt. It's not in alignment like we think. Those three stars are three dots right next to each other in the sky. One of them, the middle star, is actually quite a bit further away. But this is Orion, and here's our featured star, Rigel. Betelgeuse we'll look at in just a little while from now, too. Now let's take a look at where Rigel is in our Milky Way galaxy. And we're going to see something a little special here. Um, Rigel is still not that far from us. We'll zoom in. It's outside of the little well now, outside of that lagoon, measuring at about 860 light years from Earth. Remember, Capella was 42, Castor 51, Pollux was 34. So they're all right next to the sun here. This is the first time that we see a star that's that far away. So that's a kind of a new feature. And let's take a look at Rigel now. So this is different. Rigel is huge in comparison to our sun, noted here. And even though Rigel looks like one single blue-white point of light, it's actually three stars in the system with a magnitude of about less than one, but 0.1. So this Rigel is about 8 million years old. It's the seventh brightest star in our sky, and it's considered a supergiant. It's anywhere from 61,000 to 350,000 times more luminous than our sun, and it has 17 times the mass of our sun, 76 times the diameter. And remember what we said, the whiter, the hotter, the yellow, redder, the cooler. So as opposed to our 10,000 degree sun, Rigel measures 20,000 degrees in temperature on the surface. And sometime in the not so distant future, since Rigel has blown off all of its hydrogen and become this supergiant, it is destined to leave a neutron star or a black hole behind. And hopefully that won't happen in the next hour or so. But we are going to look at an object that was created as the result of a neutron star. We'll look at that in just a little while. Okay, so we'll go back to our winter circle, and we will continue on to the constellation of Taurus the Bull and its star along the winter circle, Aldebaran. So the constellation of Taurus the Bull has been identified with just about every culture ever. It dates back as far as 15,000 years BC. There's stories about the bull. In the classical Greek mythology, there's the story that Zeus tried to kidnap Europa by assuming the form of a white bull and carrying her out to sea. Zeus had a real problem, I'll tell you that right now, but he got around it by taking the form of many different things. In this case, it was this white bull. And this is probably why we see just the top half of the white bull. It's depicted as if the rest of the bull were submerged underwater. Let's take a look now at it in this view. And I want to point out a couple of things right here that are going to become important later. This is the Pleiades group of stars here. And this V shape is the Hyades group of stars here. And this is Aldebaran right here. And there's a reason I point that out. I'll explain more about that in just a few minutes. But as we look around the constellation, here's that Aldebaran, and the rest of the stars are in various places, various sizes and colors, meaning different heat, different temperatures. So the reason I mentioned the Pleiades earlier is because the word Aldebaran is Arabic for the follower. And it's referred to as the follower, not necessarily because of Aldebaran itself, but because the Pleiades are followed across the sky by the Hyades. And Aldebaran is one of the stars in the Hyades in this V shape that makes up the sort of the head of the bull. Aldebaran is thought to be one of the red eyes of the bull. And interestingly, I'll note right now that here's another red object, not a star, but here's Mars. And those of you that have been following the Perseverance rover know that we've got a little buddy up on Mars right now, crawling around the surface. So there's Mars right now in the constellation of Taurus, but could easily be mistaken for Aldebaran because it's also red. Aldebaran has this red look to it also. Let's take a look at where Aldebaran is in our galaxy. We zoom in and we are back in our lagoon of stars. We are 66 light years away, so a little bit further than Castor, a little bit further than Capella, but still within that same lagoon area. 66 light years, 186,000 miles per second, traveling for 66 years it would take to get to that place. Now, let's have a look at Aldebaran for real. Now we're talking. Aldebaran is huge, and it's actually two stars. It's also a binary star. So many binary stars we've talked about tonight. A visual magnitude a little bit under one. It's an orange giant, Aldebaran is, and its companion is a little faint red dwarf. Aldebaran is the 14th brightest star in our sky. It is, in fact, older than our sun. It's 6.5 billion years old. So, when it calls dibs on, on the front seat in the car, it wins because it's older by 2 billion years. It's about 44 times the size of our sun, and it's considered a giant star and cooler than our sun, of course. We know that the orange-red stars are cooler, and it measures in at 6,500 degrees Fahrenheit. It has 16% more mass than our sun, but it's 520 times about more luminous because it's just so big and getting bigger. Here's a little fun fact for everybody, those of you that remember the Pioneer 10 spacecraft, and I know a bunch of you out there remember the Pioneer 10. Well, I read, and I don't know if it's true, but I think I'd like to think that it's believed to be true. Even though the spacecraft flew by Jupiter in '73, around the early 2000s, we lost contact with the Pioneer 10. I hope that at some point that it comes back and we hear from it again, but it's scheduled to pass by Aldebaran in about 2 million years. So hopefully we'll get some information from it in 2 million years from now. And I promise you when that happens, we will absolutely do another presentation for you on the information we've got back from that and see what Aldebaran looks like at that point. So we've continued, we've covered all of the stars in the constellation. So let me just take a quick review of that. Here's Auriga and Capella, Gemini, Castor and Pollux, Procyon and Canis Minor, Sirius, the brightest star in our sky, and Canis Major, Rigel in the Orion Constellation, and Aldebaran in the Taurus constellation. So while we're here, let's take a step back to the Orion constellation and look at some of the other interesting things that are in this constellation. There's a few other uh, asterisms within this constellation. In addition to the winter circle, there are three other asterisms right in Orion itself. No wonder he's so popular. Being held out in his arm in front of him, protecting him from Taurus the bull, is Orion's shield. That's that group of squiggly stars. You, of course, know Orion's belt made up of these three stars, and we'll look at an object in there in a few minutes. But hanging down from his belt, you can see in this sort of animation, is this sword that he carries with him. And right in the middle of the sword, and this is the asterism, Orion's sword, right in the middle of his sword is this object called the Orion Nebula. And we're going to take a more careful look at that right now. So for this, I want to show you a picture that actually was taken by our main astronomer here at the observatory. That's Gordy Duval. This picture actually sort of inspired me to go into astrophotography. And you can see that these colors are all being lit by this ionized hydrogen gas that's in this area of the sky. So the stars in here are actually heating and making this gas glow. It's kind of like a neon light. You have gas inside of a tube, you run some electricity through it, and that neon glows. Well, it's almost exactly the same thing as this. So these stars are emitting heat, radiation, whatever else, and making these gases glow. The reds are the ionized hydrogen gas that's present in this part of the sky. So let's take a look at where that object is. And here we're going to travel a little bit, not too far, but the Orion Nebula is clearly outside of our little lagoon. It's 1,400 light years away from us, and it is 35 light years in diameter. Um, and I guess the thing that I would note there is that we've been looking at stars that are, several 100,000 miles across. Now we're looking at distances in light years across. So these are not star size, these are massive, covering an entire portion of the sky. You can actually see the Orion Nebula if you're in a dark spot like Tupper Lake, and you let your eyes adjust and you look right in the middle of that sword. You can see a little bit south of the belt. The Orion Nebula is right there. You just have to let your eyes relax a little bit. One of the things that I think is important to note here is that this is the gas that we see that's illuminated by the stars in that area. But this whole portion of the sky, really the entire winter circle, is one enormous nursery of stars. Um, this is the Orion Nebula here. This is a picture from the infrared astronomical satellite. And it shows you that if we're looking just at the Orion Nebula here, that all of this area has gas in it. This is detected by infrared rather than just regular light that we get. But you can see that all of this gas ultimately is going to turn into a star. It's going to compress and turn into stars that will ultimately illuminate back out, and we'll be able to see some more of these fantastic objects. Another fantastic object on the subject of fantastic objects is absolutely my favorite object in the sky, and it can be found just south of this star here, Alnitak. Let me see if I can highlight it for you. There's the Horsehead Nebula. Now, the Horsehead Nebula is also an emission nebula, just like the Orion Nebula was, but it's a little bit backwards. And let me show you what I mean by that. I'm going to start by showing you a picture that I did from the observatory here in Tupper Lake just a few weeks ago. This is the Horsehead Nebula. This is the star Alnitak. And these gases here are being illuminated the same way. They're being excited by the heat and they're glowing. However, this portion, the portion that actually looks like a horse head, is gas or dust that's not being illuminated. So it's actually a shadow. It's not actually glowing or an object. It's the lack of glowing. It's casting a shadow in front of this emission nebula in the shape of a horse head. And it's absolutely one of my favorite objects to try to photograph. Very difficult, in my opinion. And ironically, a little while ago, seriously, about a half an hour before we started tonight, one of our board members, David Aguilar, who I'm sure many of you know, sent a picture out of an image he did of the Horsehead Nebula. So this is a very popular object to try to capture. And here's the Horsehead right here. Here's Alnitak, and all of that beautiful gas being illuminated by that star. It's absolutely stunningly beautiful, in my opinion. I hope you agree. From a distance standpoint, the Horsehead Nebula is 1,600 light years away. So we'll take a look at where that is now. We're getting a little bit further out now, right? This is our little lagoon right here where everything was before. Now we're 1,600 light years away. So we're getting further and further away in our circle. Before we leave the Orion constellation, we have to talk about another star, the famous star, the big star, everyone's favorite star, and certainly everyone's favorite star last year. This is the star Beetlejuice, sometimes referred to as Betelgeuse, sometimes Beetlejuice. I'll just call it Beetlejuice because it's more fun and more approachable. Sometimes I slip and I just call it Michael Keaton. For those of you who get that reference, hopefully you know what I'm talking about. This is a different type of an object now, and this is a massive star. We'll zoom in. This is 500 light years from us, so even further than the Horsehead Nebula, but definitely out of our little lagoon area there. And I want to try to show you something cool here if I can. If I can make this happen, it'd be really cool. Here's Beetlejuice. There we go. Beetlejuice is a red supergiant star. It's the ninth brightest star in our sky, and it is so big that if it were in the center of our solar system instead of our sun, our puny little sun, it would engulf half of our solar system. It would include Mercury, Venus, Earth, Mars, and all the way out to the asteroid belt. This star actually had some action last year. You may have heard when it seemed to be fading. These supergiants actually pulsate, And Betelgeuse can vary some between 500 to 1,000 times the diameter of our sun, making it sometimes super bright and sometimes really dim. And that seems to be what was happening last year, about this time, about January last year. Everybody started to think that something was going to happen. Maybe Betelgeuse was going to go supernova. The exciting thing is that when that actually does happen, it's going to be pretty exciting because we're going to be able to see that in our sky, even during daylight. And at nighttime, it will almost certainly outshine the moon. So here's a size representation. Here's our, I hate to refer to it as our puny little sun, but in comparison, Betelgeuse is much, much bigger. It's about 8 to 10 million years old, and it's actually been dimming. It's about half, one half a magnitude to about 1 3/4 now. So it's actually getting dimmer overall. Its surface temperature, as you can imagine, is the coolest thing we've looked at tonight at a mere 5,500 degrees Fahrenheit. It is about 600 times the size of our sun, and it is definitely one of the largest stars that we're aware of. Certainly, there's others that are bigger, but this is pretty spectacular in size. So let's kind of review here a little bit in terms of star size comparison. Here are some of the stars we've looked at, starting with our sun, which of course is a star, and Sirius, which is a little bit bigger, Pollux, which is a little bit bigger, Aldebaran, which we were, frightened at the size of, Rigel, which was stunningly large to us, and here behind all of that is Betelgeuse. So you can see in comparison to our sun, we are not even a speck of dust in the universe, at least in the Milky Way galaxy compared to Betelgeuse. So that's uh, that's the Betelgeuse story. All right, let's go back and take a look just north of Orion and just a little bit north of the tip of the southern horn of Taurus. Here is a is a nebula called the Crab Nebula, and let me show you what that looks like first. And I took this picture. I didn't I didn't photograph this picture. I stole this picture from messierobjects.com because I thought it was particularly good. This is a Hubble telescope picture. Um, the Crab Nebula, you remember I mentioned that when stars are that big that they might ultimately wind up as neutron stars or as black holes. Well, the Crab Nebula is illuminated in the same way that an emission nebula is, but in the center is not just a simple star; it's actually a neutron star. That supposedly the star went supernova about 1,000 years ago. I'm going to qualify that by saying there is significant debate about that fact. But if we imagine that about 1,000 years ago, some massive star went supernova and left a neutron star behind, this is what the result comes out to look like. So that's the Crab Nebula. And we're also going to have a look at where the Crab Nebula is. And that's pretty exciting now because as we zoom in, we are no longer not even in the Orion spur. We've crossed over the dust lane and we are now in the Perseus spur of our Milky Way galaxy. This is about 6.2 thousand light years away. And the Crab Nebula is about 10 or 11 light years in diameter. So it's a pretty cool object. Let's go back to that view right there. Again, about 10.8 light years in diameter and 6.2 thousand light years away from us. So definitely the furthest object that we've looked at so far tonight. Okay. Moving on to our next object. This doesn't have a fancy name like Crab Nebula or Horsehead or even Orion. This object is simply referred to as M37. M37 is named after Messier, who was a comet hunter and started cataloging different objects along this out in the sky as he found them. As it turns out, the Crab Nebula is M1, Messier object number one. So it's number one in his list and the first thing that he looked at. Let's take a look at something else first, though, because I want to describe what an open cluster is and that's what Messier 37 is. Messier 37 is an open cluster. In contrast, what is all in contrast to other objects that are called globular clusters. Globular clusters, and this is one. This picture was taken by our friend George Normandin from Copernic Observatory in Vestal, New York. He comes up and helps out with the astrophotography conference also. So this is a picture that he did of M13. Now, this is not the open cluster. This is M37. This is the Hercules star cluster, and this is a very tightly packed group of stars, hundreds of thousands of stars, maybe even millions. In contrast, we have this object. Now, this is M37. This is from messierobjects.com also. This is an open cluster of stars. It's lessly tight, it's lessly packed together, but still collected together in the same part of the galaxy. In this case, there's about 150 stars ranging from a magnitude of 9 to 12, but probably 500 stars altogether, as opposed to a globular cluster, which could have millions of stars altogether. So let's take a look at where M37 is in our Milky Way galaxy. And here again, we are not that close. The Crab Nebula was way out here. Messier 37 is about 4,600 light years away and 25 light years across. It's in this dust lane. It's not in either of the arms or this Orion spur. It's in this dust lane in between those two spiral arms. So, but it has such a beautiful, rich contrast in the color and the size and brightness of the stars. It's one of my absolute favorite objects, one of my favorite open cluster objects to see or to image when I can. So that is Messier 37. Let's now go to our very last deep space object tonight. And I know I said if we had time, but since I don't know what time it is, I'm going to assume we have time. And that is this object right here, the Rosette Nebula. This is also an emission nebula, just like the Orion Nebula, just like the Horsehead that had a shadow in front of it. But the difference with the Rosette Nebula is that it has a group of stars in the center of it that make it particularly beautiful. And I want to show you a picture that one of our friends, Andy Metz, did. Andy comes up and he does instruction for our astrophotography conference also. This is a picture that he did with a filter on his camera that captures only hydrogen alpha, or basically the ionized hydrogen. It captures that frequency of light emitted from the glowing gas, but it's only the hydrogen gas here. And you can see that these stars in the middle also have that color also. But this is a stunningly beautiful picture that he did a couple of years ago of just the hydrogen gas within that nebula. So I love that. And in contrast, when we go to the full spectrum of colors, here's another picture from Tim Connolly from his Astro North. And here are the stars. And again, this emission nebula has this beautiful ionized hydrogen gas being lit, not just by one star, but by many stars. And this group, this cluster of stars, has kind of a unique identity all to itself. So that's the Rosette Nebula from that standpoint. But let's see where the Rosette Nebula is in comparison to other things we've looked at tonight. We'll zoom in again. Rosette Nebula, about 5,500 light years away. So not the farthest thing that we've looked at, but certainly not the closest. And it is 128 light years in diameter. It too shares this dust lane as well. So here's our sun, and here is the Rosette Nebula, about 5,500 light years away. So let's go back and make sure we can find some of that stuff again. We already went through the stars and the constellations, but as a little bit of help here, we know that we can find the Orion Nebula right on the sword, these three stars that make up the sword of the hanging from the belt, and the Horsehead Nebula right in the belt, right next to Aldebaran. We have Beetlejuice, which is a fabulously large star. We have the Crab Nebula, which is right up around this area, right above the tip of the horn, of the southern horn of Taurus. We have M37, which is right in this area of the sky. And if you use the two stars of Auriga and the knee, if you kind of find the kind of the conjunction or the intersection of those two places, M37 is right in this area, but there's a lot of beautiful stars in that area. And of course, the Rosette Nebula, right in the nostril of this of Monoceros, not the unicorn, not officially in the winter circle, but certainly a great place to look. And you can actually, if you use Aldebaran, Beetlejuice, and you go a little bit further, you'll find the Rosette Nebula in that neck of the sky. So that's where those things are located. One final bit of perspective for us all. Remember, light travels at 186,000 miles per second, or about 5 trillion, 5.8 trillion miles per year. Sirius, the closest object that we've looked at tonight, is about 8.5 light years away. That's about 50 trillion 50 trillion miles. And at 55 miles an hour, it would take about 38 billion years, or 38 billion days to get there. And that's without stopping for a snack or at a rest stop along the way. The Crab Nebula was the farthest object we looked at tonight at 6,200 light years away. The Andromeda, the Milky Way galaxy, is about 100,000 light years in diameter altogether, maybe a little bit more. And our closest galactic neighbor is the Andromeda galaxy at a whopping 2.5 million light years away. So essentially, when a photon or a light beam leaves the Andromeda galaxy, it will be 2.5 million years until that light catches up with us here in the Milky Way. And for some perspective, everything that we looked at tonight is in this little circle. Here's our sun. Here's the Crab Nebula way out over here. And everything else we looked at is in this little tiny area of the Milky Way galaxy. We are never looking at things, way out on the other side. Pretty much everything we see in the night sky is in this neighborhood right here. We're not seeing stars that are way over here. So keep that in mind the next time you're looking out at the sky, that our view is very, very slight in comparison to the vastness of our galaxy and our universe. So with that, I'm going to stop my sharing my screen and come back to normal view and see everybody and say hello. Um, it is now 8:12, so we are a little over time here. But before we go, I do want to make sure that I add some of the links that I promised earlier to our chat, and I'll paste it right into our chat there so that you all have that. Our phone number, our website, Facebook. This presentation will be on YouTube within the next day or two. And most importantly, I say, because I'm very interested in this building behind us, this is the kind of a model of the Astro Science Center that we're looking to build in addition to our roll-off roof observatory, about an 18,000 square foot building with planetarium, a research grade telescope. Oops, sorry, research grade telescope over here, planetarium, classroom, lecture hall, exhibits. I mean, just a fascinating place to be and spend plenty of time. There's our link to donate down at the bottom there. At any level, we would certainly appreciate that. So with that, I'm happy to stay on for as long as anybody wants. We can chat about anything you like. Hopefully, something in the Great Winter Circle, but I'll be happy to stick around, take some questions, see if our students from the high school astronomy class maybe have some questions to ask. I see Ethan's there. Hi, Ethan. I was hoping you'd be here tonight. You never miss, do you?
Um, so my question was like, what if like a billion stars collide into a planet like at faster than the speed of light?
So you're thinking that a star and a planet might crash into each other.
Yeah, like
Right.
what if like a billion stars crash into a planet? Like what would
I think,
happen?
yeah, that's a great question. I think that would be bad news for anybody on the planet for sure. Uh,
Yeah, like would it turn into a nebula?
Well, this star itself has so much mass to it that any one star could suck a planet into it. If we weren't spinning around and keeping our distance from the sun, if we were just kind of sitting still there, we eventually would kind of drift into the sun. Also, thankfully, we're spinning around, kind of like a merry-go-round. You know, when you're on a merry-go-round, you feel like you're going to be flung off the edge of it. Well, that's kind of the way planets are spinning around the sun. They're being flung out at the same time that the sun is pulling us in, and it creates this kind of equilibrium so the sun doesn't crash into the planet. But it is possible. There are other things that are flying out there, meteors or asteroids sometimes get off course and may collide with the sun or any star and just disappear into the sun. If there were a lot of stars, if there were those two, like Capella had those two yellow stars that were spinning around each other, that would cause a massive something to happen. And Eileen O'Donoghue did a show last year on gravitational waves. And if you recall, I believe, and I'm not sure if she's with us tonight, but I'm going to say that I think that that gravitational wave was caused by this enormous explosion of these two stars that were circling around each other. So I think that's the way it would go. But certainly, if there was a planet involved, nothing on that planet would be very happy that day for sure.
Yeah,
Great question, though.
thanks.
You bet. Good to see you. It's funny. Usually, I'm the host, and there's a presenter. Tonight, I'm kind of in both, so not sure what to do at this point. Any other questions? Anybody want to
Just
see any
one
of
quick,
those images
just
again?
one quick little one.
Sure, Bridget.
Why did they call it the Great Winter Circle? Why is it called the winter?
It's okay. That's a great question. Well, you know the way the Earth spins around the sun,
Mm-hmm.
its orientation faces uh, different directions in space at different times of the year. So
Yeah.
in the summer, we're oriented in such a way that we see the summer triangle with Vega, Deneb, and Altair making that huge triangle in the sky with Cygnus the swan flying through it. But in the wintertime, we're sort of facing a different way. So the another portion of the sky becomes visible to us, and we see the winter circle. In a
Except
couple
I
of
always see Orion, whether it's summer or winter. I seem to see it all the time.
not likely in the summertime. In the daytime in the summer, you would see Orion, but at the night in the night you wouldn't see Orion. I guess it depends on where you are. I mean, I suppose it's possible.
Oh, maybe when I was in Minnesota, I saw Orion, or who knows where.
Or
Who knows?
maybe just
Yeah, I do a lot of traveling, so that's
yeah,
true. I forgot about that.
sure. But
Where
that
in Orion is the northern star? Is it on the Dipper?
well, that's a great question. Let's kind of go back to here. Let me share my screen again and go to that area here. We use and many of you know, especially those in astronomy class. I
Oh,
hope
there.
you know the answer to this. That the Big Dipper, the edge of the Big Dipper, these two stars form a straight line, and it points to Polaris, the North Star. And
Ah,
north. So if you see the Big Dipper, find the bottom edge of that pan, and even if it's oriented differently at a different time of night or different time of year, these are circumpolar, so they will always be above the horizon. And notice that the Big Dipper points to Polaris, which is the tail of the Little Dipper or Ursa Minor.
got it.
So
Got
there
it.
you can find.
I always thought it was down in the Big Dipper.
Nope, that's a common thought. I certainly can understand why people think that, but you can find the North Star Polaris by using the Big Dipper. So close
Thank
enough.
you. Thank you very much.
You bet. Good to see you again.
Thank you. Love being here.
Yeah, it's always fun.
Hey,
Anything?
Seth, I have a question for you.
Hey, Jeff.
Hey, how you doing? Great job tonight.
Thank
It was
you.
a really good presentation. So this program you're using, this is Sky Safari. What was the other program that we're using that showed the relationship of the distances of the stars in the constellations? That was really cool.
Isn't that cool? I love that for that program. That is called Night Sky.
Night Sky. Okay.
And it is very limited in that the navigation, first of all, is very difficult, but it's limited in that you really are limited to the field of view that you can use. And this is it. This is the widest field of view that it allows you. But simply by identifying, oh, and you know what we should do, Jeff? You and I just did the Artemis thing. While we're here, let's take a look at Mars. Remember, Mars was in.
Mm-hmm.
Not only can you look in 3D at the various stars, and I just do that by clicking on the name of the constellation. So that's kind of cool. But I can also double click on, here's Aldebaran. We can take a kind of a close-up look at Aldebaran. But even cooler, since we were just talking about Mars, is that I can take a closer look at Mars also. And actually open Mars up.
Ooh.
What's inside. So cool, right?
Yeah, that's great. That's great.
And in addition to that, I can see what the rest of the galaxy looks like from Mars's perspective. So now I'm actually sitting on Mars looking out at the sky instead of being on Earth looking towards Mars. So that's kind of a handy feature also. So this is called Night Sky. It's relatively new to me. I just started using it, but I really enjoy it for that feature.
Excellent. Thank you.
And these are all available for download. There's nothing that I use tonight that is not available for download. In fact, the version of Sky Safari that I used is the Pro version. And, you know, instead of being 99 cents, maybe it was $9.99, or at worst it was $29. But it allows you to control your telescope also if you're interested in doing that kind of thing. So it's a lot of fun.
I was wondering if I was in another part of the world, like Europe or or well, even closer, Mexico or California or Manitoba, would I look up and see this exact same winter circle?
Depending on how far north or south you were, you would see it either more above your head if you were north, or you would see it closer to the horizon as you reach the equator. Do I have that right, Jeff? That sounds right to me. I think that's right. So yes, you would see it, but it would be slightly higher or lower in the sky.
And if you were in the southern hemisphere, close enough to the equator to see it, Orion would be upside down.
Right. Does that make sense, Ginny?
It does. Thank you.
Okay.
Hey, Seth, Jim Webster from New Jersey.
Hey, Jim, good to see you again.
Besides Sky Safari Pro and Night Sky, were there any other programs you used tonight?
There was PowerPoint. Let me just look at my bar down there. Nope, that was it. All of them. One of the features you may have seen is when I click on a star in Night Safari, I can look at it in Galaxy View. That's a feature of Sky Safari.
Okay,
So that might be what seemed like another program. But it's
awesome.
handy. Very good for perspective. I started toying with the idea that I should call this this presentation perspective, because it really focuses that on the fact that we're only looking at such a small area of our Milky Way galaxy.
Awesome.
Yeah.
All right, thank you.
Seth, I have something to add.
Hey, Mark.
How you doing, buddy?
Good.
Nice job tonight.
Thanks. Good to see you.
Just as a reminder for those that are just casual observers that like to just go out with a pair of binoculars at night, the Orion Nebula is usually pretty detectable with at least a pair of 10 by 35s or 10 by 50 binoculars. So it doesn't take an exorbitant amount of equipment to see some of these things that Seth presented tonight.
Absolutely. Absolutely. Yeah. And there's a bunch of things. We looked quickly at George Normanden's Hercules star cluster. Same thing in the wintertime. That's great looking through a pair of binoculars, and so much more portable than a telescope.
Yeah, a lot cheaper too.
That's right. That's right. Thanks, Mark. That's a great point. What else? Anything else out there for?
Hello, Seth. Hello, Seth. I wanted to ask a question about the lifespans of these stars. You mentioned several of them, and there was a tremendous range in their lifespan. And I was wondering what is it that makes one star develop faster than or slower than another star? Why are some of them done with their lives after just a few million or 10 million years, and other ones go on and on for many billion?
Yeah, I mean, I'll defer to Jeff on this more specifically, but it's mostly having to do with the pull, the gravity and the crush, and how quickly it exhausts hydrogen and makes helium or other elements. But Jeff, you can answer that much better.
Actually, you're correct. Yeah, so it's the rate of fusion, the conversion of hydrogen to helium, and that's what creates the energy that is emitted, that creates the sun, or the heat and the light radiation that we experience from our sun and from stars. And it's the same thing comparing a gas guzzler, some vehicle that has a huge V8, and another car that has a very small 4-cylinder engine. They might have the same size gas tank, but the larger engine is going to run out of gas more quickly because it's using gas that has a lower miles per gallon rating, or in the case of a star, a much larger star, much more massive, is going to burn through its supply of hydrogen much more rapidly. And so typically extremely large stars won't live very long. And by very long, we're talking on the orders of, tens or hundreds of millions of years. That's actually a very short period of time, maybe only a couple of billion years. Our sun will live a total of about 10 billion years. very small massive stars could live 2-3 times longer than that. So it all has to do with the physical size of the sun and how fast it's burning through its hydrogen fuel.
And also what happens after it burns through that. You know, in the case of planetary nebula, you know, the all of that gravity pulling the gas inward while the energy is pushing it outward. Ultimately, that battle is lost as that fusion stops and the mass goes away. The cloud of gas just sort of, you know, poofs out like a bad hair day, as opposed to these supermassive stars that can't contain their own weight and just do this, you know, this symbol crash on itself and create these supernova. Great question. I can't wait. I was really hoping for something in Beetlejuice last year. That was that would have made my year. Would have made everybody's year, I suppose. Anything else out there?
What is the biggest star that we know of?
I wish that I had this video. I honestly, I can't remember the name of it, but Ethan, I'm gonna find this video for you. And Jeff, you probably know, or somebody knows the name of the biggest star.
There is a bunch of different candidates, and some of the really massive ones are very, very unstable. So they just have like catalog names. So, but yeah, there's a lot that are tremendously large that are basically the photons of light that they're emitting are actually tearing them apart. There's so much radiation pressure from the light that they're emitting. So yeah, they're very, very large, much larger than Betelgeuse.
There's Ethan, there's a video that I'll send to you. I started to mention of that takes you through you know, the Earth to the sun, and then each next size star, and it ends with this just, you know, unbelievably large star that you can't even see the sun anymore. I'll find that video and send it along to you. I think you'll really like it.
Thanks.
You bet. All right. Well, if that's it, I want to thank everybody for coming tonight. I'm so happy that we did this. This was actually supposed to take place in January as to kick off the Orion series of lectures. COVID got in the way of that, so we just flipped and did it in March instead. But I really enjoyed doing it, and we'll post it up on YouTube within the next day or two. Remember those links if you're interested in becoming a member. Certainly give us a call or email info@adirondackskycenter.org to reach one of us. We'd be happy to get back in touch with you soon. So with that, clear skies to you all, and have a happy March. Thanks.